The Creative College design is aimed at providing an enthusiastic and cooperative learning environment for a multinational institution with 1,500 students ranging in ages from 3 to 18. It has been designed in accordance with the BREEAM and Passivhaus standards, with environment, community, and user-friendliness having been the primary focus of our design. To maximize use of natural environment, a holistic design for lighting, ventilation, and rainwater harvestment has been employed to improve resource management. Furthermore, material choice, energy sources, and an integrated design approach on a building element have been discussed to illustrate an overall improved building performance.
The college is based in suburban Bristol, spread over an area of 100,000 square meters, with no significant obstruction or vegetation. The design provides a holistic approach of integrating the school facilities within the already existing natural environment and mitigate its future degradation. It further facilitates the students' interaction with nature and provides an overall healthy environment for their growth. Shared facilities, as shown, has been placed in close proximity to the primary secondary schools and also have an accessible route for use by the wider community. Learning facilities in here have been placed at the heart of the school, providing a spatial layout to promote informal learning and encourage interaction and after-school activities. Moreover, the college layout integrates the students, staff, and parents, improving the overall experience for each individual, encouraging social interaction to help gain from each other's experience. A detailed accessibility design was prepared to ease inflow and outflow of pedestrians, cars, and public transport for the school. Ramps and elevators have been placed throughout the campus to ease access for people of all abilities. The classroom, labs, and informal teaching areas collectively make up learning grids, integrated with natural environment through the design of buildings, encouraging student enthusiasm and engagement with nature. Innovatively designed small study areas have been placed along the library's facade, in close proximity to the surrounding nature, providing quiet and comforting environment for educational learning.
To ensure maximum daylighting, the buildings have been orientated in the north and south direction. Weather reports suggest that Bristol experienced 9 to 16 hours of sunlight during winters and summers respectively, ensuring daylight as a reliable lighting source. The windows along the south facade have been designed to be comparatively smaller and have external sun shading to avoid unnecessary solar gain and consequent overheating. Design aspects such as roof lighting and the cutout of the corridors placed on the first floor and the second floors ensure maximum natural daylight penetration, improving white light availability to the student, increasing their performance. To ease visual comfort at different levels within the building, shading equipment above and at adjacent surface to the windows are used to avoid glare and reflection, which could have affected a student's ability to perceive. Wider graphs illustrate a reliable source of rainfall throughout the year in Bristol. Through underground placed water tanks and green roofing, this water can be harvested to be filtered and used for drinking purpose, or if not, then can be used for the toilet and gardening purpose. The ventilation strategy makes use of rainwater harvesting tanks. The water acquires relatively warmer or cooler temperature dependent upon the external conditions. Additional mechanical fans are attached to compensate when wind speed is low. The water body is connected through pipes, moving the subground warmer air in the winters and the cooler air in summers into the building's floor through air vents, located at the lower end of each floor. Stack effect is used, whereby the carbon dioxide condensed stale air is pushed upwards and released into the atmosphere through the chimney. A well-insulated building fabric coupled with the natural ventilation strategy can help reduce energy demand significantly. Building plant rooms are localized to each building, increasing varied internal environment as per occupant needs, and have been placed in areas with minimum daylighting penetration to improve space usage efficiency. They have a passive ventilation approach of placing plants within self-containing cooling chambers that makes use of a fan to provide external cool air, ensuring optimal conditions.
Straw bale is the preferred material choice with regards to Green Guide rating that takes into account a material's life cycle impact assessment. It is both locally produced and responsibly sourced. A typical cross-section includes clay rendering, straw bale, timber frame, and external paint layers. Furthermore, it is a highly sustainable material with low cost and good noise attenuation properties, coupled with a good fire resistance, providing an overall comfortable and safe environment for occupants. Straw bale has the least embodied carbon due to high carbon sequestration in comparison to commonly used construction materials. The repetitive facade design allows for prefabricated panels to be used, improving construction efficiency through reduced labor, time consumption, and material usage. Climatic information suggests PV cells are a reliable source of energy within Bristol, with the city's sunlight having the potential to harvest 1,000 kilowatt hours per square meter annually. They are positioned facing the south orientation where there is no visual obstructions to maximize solar light gains and are angled at 45 degrees to facilitate easy cleaning and efficient usage. The green photosynthesis plants on the roof act as a multi-purpose design aspect that not only helps reduce the surface runoff water but also significantly cuts down on reflections within the teaching facilities. It also helps lower down ambient temperatures and provides carbon sequestration, improving indoor air quality throughout the school. Overall, green roofs have a longer lifespan as compared to typical roofs. Moreover, the school is designed in a manner to facilitate future expansion through efficient land usage and building positioning. Each of the building is orientated and positioned to improve natural daylighting and harmonize the school's association with its surrounding nature. Sustainability is at the heart of the project's design, construction, and operation as it is intertwined with the building's overall environmental, economic, and social performance.